Right, so let's set up our simulation. So I'm going to do it inside the crowd source. So we've got the agents coming in there and they're being scattered. Obviously they're too small. So let's come to the randomization tab, put the scale back up to 1. There we go, we got them all there. So I don't want to randomize the state. Let's do, initial state, we don't want that at all, so we just turn that off. They're all in T-pose. And the initial state, I want it to actually be in ragdoll. Okay, we're just going to go straight into ragdoll with this. Maybe, before we do that, I'll go back here and put them into the sitting. So they'll start in this shape, in this pose, but they will be in ragdoll straight away, right, when we simulate it. So let's grab a configure, agent configure, no, not that. Agent constraint network, that's it. So once I drop that down, this will use the information that we set up earlier on, the cone twist constraints and the collision geometry to build our constraints, right? So now if I drop a null on the right, just to have a look, don't see anything first, but if we visualize the points, we can actually see them. And each one of these is actually a primitive, right? So if I make a selection there, I think if I do that, go into geometry spreadsheet, you can see we've got primitive attributes on there, right? I think you could probably I could probably move one of these. Maybe you'll see it. See it? No. Let's see if I just grab one of the points like that. And then, I think you can see the primitive there now. Okay, so we got a point with two primitives connecting the collision geometry together. Right, so there's our constraints, and both need to go into the dop network. Not that, dop network. So put the agents, that's what's coming out this port, at the left into the first input, and then the constraints into the second. You can do it how you want, so I just find this easier and cleaner. We'll go over these a bit more later, okay? But these are the kind of attributes that you want to set up on the constraints for how they behave in the simulation. You can see here the same thing we were using earlier. No, sorry, it's not that. This will, if you don't set anything up, then it will. If you don't set up any limits to those constraints, then they will just be pinned in place, right? So let's dive inside here. So first, we'll just set up the basic crowd solver first of all. So we need a crowd object. Okay, we can. I'm going to use a crowd source this time. Connect that up in there. And there's it's basically a pop source, but with setup for a crowd, right? We want to use the first context geometry. There we go. We've got our agents, but obviously they are. It's all messed up because we don't have a state. So crowd state. Connect that up. Call this ragdoll. And set it to active ragdoll here, and there we go. We got our ragdolls, okay, but this is not going to actually simulate yet, okay? They're just going to be sat there static. We don't have any velocity acting on this. So we need a bullet solver also, and I'm going to use a rigid body solver. Actually, you can use either, but I'm going to use a rigid body solver so I can use pop forces with this. So to connect these together, we need a multi-solver. Okay, and then whoops, that doesn't go in there. The solvers go into this part on the right. Okay, and then into the left we put the objects like that. and connect it up there. Okay, we'll want some gravity. You can see that they actually started going down already. We could drop a ground plane for the, you know, we won't be using it later, but just so we can see something happening. Connect that in, always onto the left. Okay, so we got a bit of a problem there. So obviously we don't have any constraints. I'm going to set them up here. Excuse me. You can set them up at the top or down below, up to you. So we need a constraint network, and that was our second context geometry, right, in here. And then we need some constraints. So we need our cone, twist, let's see, cone twist, constraint relationship, yes, connect that up. And then the name is what's important here, which is not the same as this. Let's check if we can see it here. The constraint name. If we come here and then on the primitives, we should have a constraint name here. Constraint name. You can see there's cone twist, capital C, capital T, and this is, it's very important that that is the same as what goes in here, the data name. Okay, so cone twist without conrel at the beginning, and there we go. You can see we've got visualizers for all of our cone twists, which are a bit over the top. Other things we need to do, so all of these will be multiplied by the values that we set up beforehand. So we're going to set all of these just to 1. Okay, and then you can see that it's kind of dialing it in. And there you can see that allow initial violation of limits. This will all be 1, 1, 1, 1, 1, and then this is all okay. Motor, we don't want that. And then we want this disable collisions, which will stop when two objects are constrained to each other. They won't collide with each other. Okay, I believe that should be all we need, and it should work. Let's just try it. And there we go. If I turn off the guide, which is a bit distracting, in guide options, show guide geometry, there we go. Press play, and we got our simulation there. Perfect.